Today we have our exponentials, our RAD, and I would like to once again review over the last few rules that we have. We have the product rule, and that says a to the m power times a to the n power is equal to a to the m plus n power. Next we have our quotient rule, and it says a to the m power over a to the n power equals a to the m minus n power. Next we have our negative exponent rule, and that's m to the negative a is equivalent to 1 over m to the positive a, or 1 over m to the power of negative a is equivalent to m to the power of positive a. And lastly, we have our power rule, and that says a to the power of m raised to the power of n equals a to the power of m times n. So you simply multiply the exponents, you flip the exponents, you subtract the exponents, or you add the exponents. So let's go ahead and move on to our next part. Beyond easy. Example 1, 4 to the power of 1 is equal to, well, 4. Okay, so in that case, I want to go ahead and take this a little bit further. If that's the case, what if I gave you 4 over 4? Well, I would say that that's equal to 4 to the power of 1 over 4 to the power of 1. Beautiful. Well, in that case here, I could use my quotient rule and say I have a base 4, and I have my exponent 1 minus 1, which is equal to 0. But the thing is, we should have known this from the very beginning. Well, 4 over 4, that reduces to 1. Okay, so let's have another example. What if I gave you a squared over a squared? Well, of course, we could expand that a little bit and say a times a over a times a, and, well, that reduces to 1 and 1. So essentially, I could have used the quotient rule and said a to the power of 2 minus 2 is equal to, well, 0, but I already knew that both of these are going to reduce to 1, leaving me with simply 1. Next example. What if I gave you x to the power of 0 and y cubed? Well, we already know that if we have something to the power of 0, it's equivalent to 1. So I could say 1 times, and, well, I could expand that. Y times y times y. Now, did I even really have to expand it? No, not really, because that's just 1 times y cubed, or simply my final answer would have been y cubed. Awesome. So we pretty much already have our conclusion of when a base is raised to the power of 0, it's simply equal to 1. So therefore, our last example, what if I gave you a group of 25 f cubed g squared, all being raised to the power of 0? Well, I could simply use my power rule, and that was what we were talking about yesterday, that we can more or less distribute this out to each and every one of these factors. So essentially, I would say 25 to the power of 0 times f to the power of 3 times 0, and g to the power of 2 times 0. Well, that's 25 to the power of 0 times f to the power of 0 times g to the power of 0, all of which will be reduced to 1 times 1 times 1, which equals 1. This is page 16. Don't forget to label it. And flip it on over. Let's again begin with 4 to the power of 1. Well, that means that I have 4 times itself one time. Just like 4 squared is equivalent to, well, 4 times 4, which is eventually 16. And 4 cubed, that's 4 times 4 times 4, which is 16 times 4. Oh yeah, we dealt with that one earlier. That's 64. Okay, now that's fairly simple. Sorry, I said cubed and I didn't write it. Now, let's try and take this backwards. What if I gave you 4 to the power of 1/2? Interesting. Now, last time I only had it raised to whole numbers, but we already discussed that a whole number can easily be turned into a fraction by putting it over 1. Over 1. Okay. So if I think of it that way, let's do some scratch work over here. Well, if I have 4 to the power of 1, well, that means I'm just going to have a 4. Then I have divided by 2. Now, what I had some of my students tell me was, well, it sounds like maybe the answer would be 2. Some of them went with 8. Now, let's try and make or rationalize our 2. So, why are we thinking 2? Well, we know that 2 times 2 gives me 4, and that's raised to the power of 1. Okay, so that's getting me somewhere. 2 times 2 is equal to 4. But I kind of need it to be 4 to the power of 1/2. So I do have 4 to the power of 1, and I have this here 1, 2 times. Okay. So 4 raised to the 1/2 power would give me 2. Well, what if I asked for 25 to the power of 1/2? Well, again, I have this 2 here, so that would lead me to believe that, well, I need something times something equals 25 to the first power. Oh, well, that would be 5 times 5. Okay. So let's try this again. What if I gave you 8 to the 1/3 power? All right, well, now this time I have 3 blanks. 1, 2, 3. And it should give me 8 to the power of 1. Well, we know that one. That's 2 times 2 times 2. Okay. Well, how about 16 to the power of 1/4? Okay, well, let's get 4 blanks. 1